we are going to do, we talk about the exponential function and the natural log function the other day. So we have officially one more section to cover, and that would be the inverse trigonometric function. But we have to pause and we give you another topic that's going to be used in calculus 2. This section usually in your college used to be covered in calculus 2. But, you know, in other places when I teach at university, we cover it in calculus 1. But it's been decided over here since I think last year that they're also going to covering this section in calculus 1. So that's why we are going to cover that one first, because it's very much related to the exponential function and the log function, and that would be very useful for calculus 2. Then we come back and we finish that last section. So what I'm going to do, I'm going to finish that one today. Then tomorrow we are going to go over the practice quiz number 4, which is very important for us because 6 questions from that quiz would be repeated on the final. So that gives you the chance, although you can drop your lowest quiz, but you better not, try to take this course, to take this quiz, even if you want to drop it, because that gives you an idea that how we're going to write it down and how going to be marked done or the grading, etc. So don't slow it down. So we go over that practice quiz tomorrow, which is going to be part of our final review. Then on Monday, I give you the inverse trigonometric function. And then on Tuesday, I review some more problems for you, okay, especially from that quiz number 4. And we are not going to have any official lecture on Wednesday and Thursday. So that gives you time to prepare for your test. Okay, you know that. The window for your final are going to be starting on Tuesday, Wednesday, and Thursday. So we finish everything on Tuesday. But I'll be available on Wednesday. If you have any question, okay, you will let me know. So that would be our plan. Okay, any question? Very interesting section. Pay attention to give you one question of this section on the final and on quiz 4. That would be very useful for you if you intend to take calculus, calculus 2. So let's go and check this one. The section number is going to be a little bit different because it's from calculus 2. But if you're just following your textbook, it is going to be section 8.7. Don't worry, you don't need anything to get to know it. So this is it. I marked down today as a Wednesday. Okay, it's going to be Wednesday. I think it's the 26th. So we are going to look into this section. It's 8.7, I think, officially. I haven't checked it, but I think that's the case. In your book, it's 8.7, and it's going to be called indeterminate form. Okay, so what is going to be indeterminate form? It's a kind of a special method for finding the limits of functions. Okay, what is that expression? Indeterminate or indeterminate forms. So what does it mean? This means that you are going to find the limit of a function, mostly a rational function. You arrive at 0, 0. Remember 0, 0? We did it at the beginning of the course. In that case, we say, oh, 0, 0. Our interpretation was that there was a common factor. Eliminate the common factor, find the limits. Those type of arguments are going to be used when you have polynomials. But mainly, these type of methods would be used when you have something like a trigonometric function, okay, a natural log function or exponential function. So we are not going to be able to talk about those type of formulas that you did it before. And since we call it indeterminate, because there is a solution to your problem, but there are many, many solutions. So you cannot determine which one is yours. That's why we call it indeterminate forms. Now we're going to list all the possibilities and explain to you how we're going to do it, okay? So the first case that we are going to be considered is going to be indeterminate forms of the type, okay, the most famous one. This is indeterminate, okay, forms of this type, of type 0, 0. Okay, so you try to find a limit of a rational function, you arrive at 0, 0. Then you say, oh, it's an indeterminate form. Now, how are we going to take care of it? In order to take care of it, we have a very famous theorem. Okay, so you are going to apply this theorem. What is this theorem? This theorem is famous by the name, French name, okay, L'Hopital. This is the way we're going to pronounce it. L'Hopital or L'Hopital. L'Hopitals. L'Hopital rules. In some book they ask, they put an S here, but when they pronounce it, they don't pronounce the S. But it's popular, we call it L'Hopital. L'Hopital rule. Okay. What is going to be the L'Hopital rule? And the L'Hopital rule will tell you that you say if you get this 0, 0, then the behavior of a limit of a kind of a rational function that you have. Suppose you have a function f of x on the top, g of x on the bottom. So the L'Hopital rule will tell you that the behavior of a limit of f of x over g of x in this case is the same as the behavior of the limit of f prime over g prime. So the behavior of this expression and the derivative would be the same. The derivative is easier to handle, then we can use it in order to get to graduation. So this is the official version. Suppose we have two functions. Okay, suppose the functions, two functions. The functions f and g. F and g are differentiable. Okay, are going to be differentiable near a number a. Near means you don't care about the a, around the a. Okay, in very much all the cases, they assume that this differentiability should be at a, but it's not the case. That's a special. So we just, and when x getting closer and closer to the a, then the derivative of the function at x max exists. If it is also differentiable at a, it's a bonus. Okay, so suppose this is the case such that the following conditions satisfy. First one, the first condition is that the limit of f of x goes to a. This a can be even positive, negative, infinity, doesn't matter. Limit of f of x goes to a is equal to the 0. And limit of g of x when x goes to a is equal to the 0. So when you consider the quotient of f of x over g of x, you have the 0, 0 case. Okay, so this is going to be number one. Number two is limit of f prime of x over g prime of x. X goes to a, the ratio of the derivatives. If this limit exists, is equal to the L. Okay, so you have the 0, 0 case. Then you check this limit, you just form a f prime over the g prime and x goes to a, you find out that this limit exists. If this is going to be the case, then the limit of the original one, limit of f of x over g of x, when x goes to a, is also equal to L. That's it. That's a L'Hopital rule. So as I talk about it, you are going to be looking for this one at the beginning. And when you take the limit of the top and the bottom, you happen to have 0, 0. As soon as you have the 0, 0, then you are going to check this limit. Limit of the, it's not a quotient rule, it's the quotient of the derivative. You check this limit. If this limit happens to go to the 5, you go back and you see that the original limit is 5. Okay, very easy, easy rules if you like to do it. It's not difficult to prove, okay? As usual, if you have anything interesting to prove, you have to use the mean value theorem. You use the mean value theorem to the f and the g, this, you know that you get some f prime of c over there. So it's going to be kind of f prime c over g prime of c, and then you can manage it. If you are going to be a math major, this is one of those problems that you have to prove. Okay, but we are not going to prove it in this course. Okay, and a story about the L'Hopital rule. You see this theorem, if you ask anybody, they refer to it as a L'Hopital rule. L'Hopital hasn't done anything to prove this theorem. This theorem was proved by Cauchy, Agustin Cauchy. Both of them are French mathematicians. Agustin Cauchy proved the mean value theorem that you did. He extended the mean value theorem for 2 functions, and then he applied it to prove this theorem. And now, why we call it L'Hopital rule? L'Hopital in France, he was a very famous teacher, math teacher or the math professor. And his students later on, a group of students, they collect his lecture notes and they publish a book in calculus. In the book, they refer to this theorem as a L'Hopital rule. But he was a good teacher, but he didn't do anything to prove this theorem. Okay, but you know, it's we don't mind, and we are going to call it a L'Hopital rule. Okay, so this is it. And so it's important to be able to apply it to get it. This is the most popular case for the indeterminate form. Any question? So let's see how you operate. It's important to be if you can apply it. So we are starting with this example. Okay, there you are. Example. Maybe would like you to find each limit. One of them would be given to you on this quiz, and of course on the final. Find each limit. I give you a couple of famous. There are a couple of famous ones, and you know the way we do it is just working on this famous one. Of course, again, if you take calculus 2, at the end of the calculus 2, you are going to have another method to take care of these problems, but not in calculus 1. Okay, so over there they ask you to find it with 2 different methods and compare them together. So there you are. This is the first one. You want to find the limit of. Okay, it's going to be limit of, for example, e to the 5x. Okay, e to the 5x, and this is going to be -1, and this is minus 5x. Okay, divided by x squared. When x goes to 0, it's very famous limits. It's a 5, you can have 2x, 3x, 5x. It's a famous one. Again, it can be done in calculus 2. So what you are going to do first, you have to confirm that this is 0, 0. As usual, you see, as usual, remember previously, we just substitute. So do it again. You have to confirm it, otherwise you cannot use it. So the solution is going to be, so confirmation, we substitute to see if we can get it. So I just repeat it again, limit of e to the 5x -1 minus 5x over x squared, and x goes to 0. If you substitute, that gives you e to the 0, e to the 0 -1 minus 5 times 0 divided by 0. E to the 0 is 1, and this is 0. So that gives you 1 minus 1 over 0, and that gives you 0 over 0. So have a case in determinant form. You see, at the beginning of the course, remember we say there is a common factor. Yeah, this you can use those type of ideas because we didn't have this formula. Those type of ideas for the polynomials, not for these type of problems. There is a common factor, of course, but you cannot find it. You need some other methods. We call it power series methods. So what you are going to do, I have the case. So start applying the L'Hopital rule. Applying the L'Hopital rule means instead of finding this limit, would be the same as the limit of the derivative of the top and the bottom. This is the way we write it down. Say, oh, okay, now I can start it again. Is the limit of e to the 5x. Your writing must be, okay, precise when you apply it. X goes to 0. Say, oh, okay, by the L'Hopital rule, L'Hopital rule, you can say HR if you like, L'Hopital rule or L'Hopital rule. What you are going to do, this is going to be the same as the limit of x goes to 0. Now differentiate. Derivative of the top, you see f prime over 0, not quotient rule. Just derivative of the top divided by derivative of the bottom. Derivative of the top, derivative of exponential function. Remember, exponential function never change, would be e to the 5x. But remember, you have to multiply by u prime. U prime is derivative of the 5x, which is 5. If you miss this 5, then you cannot continue. Okay, so I'm just using this fact that the derivative of, remember, e to the u is just u prime e to the u. Exponential function as is times it by u. Derivative of 1 is 0, derivative of 5x would be minus 5. Derivative of the x squared, 2x. Okay, so I form this f prime over g prime. Now repeat it again, substitute. If you substitute x equal to the 0, the top would be 5e to the 0 minus 5, and this would be 0. E to the 0 is 1, so that gives you 5 minus 5 over 0. You get 0, 0 again. See? So what you do, you are going to continue. You can apply the L'Hopital rule, okay, L'Hopital rule, as many times as you like. So you come back and you continue. So the continue would be, again, I'll go on, L'Hopital rule, once more, to this one, differentiate again. It's going to be limit of x goes to 0. The bottom derivative of 2x would be 2. The top, again, 5 is a number, it's going to be 5, times derivative of e to the 5x. Derivative of e to the 5x, again, is would be e to the 5x times 5. So it's going to be 5 e to the 5x again. Okay, derivative of 5 is 0. X goes to 0, 5 times 5 would be 25. So that gives a limit of 25 e to the 5x over 2, x goes to 0. Now, if you substitute, the top give you 25 e to the 0, the bottom one give you 2. E to the 0 is 1. So 25 over 2 is the limit of the given function. And you're done. See, very nice method. And you may have to try it several times. So be patient and continue. Okay, you don't need it, but I rewrite the original one to just confirm the result. 5x minus 1 minus 5x over x squared, x goes to 0, is equal to the 25 over 2, and you're done. Any question? So make sure you write it down precisely. I've seen some people, they don't write these limits. It doesn't make sense. You see, the limits are the same. So confirmation first. Confirm that this is 0, 0. Sometimes you may substitute and give 2/3, 1/2. Then you're done. So how do you know that you have to use the L'Hopital rule? So that's it. That's going to be the limit. So we start with the function derivative, not the quotient rule. You see, f prime over g prime. Lift up the top. Remember, exponential function never change, but you have to multiply u prime, which is 5. Okay, and then you simplify, you get 0, 0. So you're not done. You continue. Repeat it again. Lift off the 2x is 2. You get another 5 times 5, 25, and you substitute, get 25 half. So that gives you the final answer. Any question? That's the most popular case for this type of problems. Again, there is another method to do it, but you need calculus 2. At the end of calculus 2, then you arrive at this one. We call it power series method. Okay, so this is the first one. We are interested in this type, not polynomial types, because the polynomial you did it before, and you see these are the one that force you to apply the L'Hopital rule. I'll give you another example. This time is going to be trigonometric function, because these are the possibilities that we have. Okay, let's see what's going to be the trigonometric one. The trigonometric one, again, this limit is very popular. You want to find the limit of, okay, you want to find the limit of this to say, for example, 1 minus cosine. You have a couple of them, of course, in the final review. A couple of good one. Again, this limit is going to be given to calculus 2. There are different ways to do these limits. Even there are 4 different methods to be able to do it. But we want to try the L'Hopital rule or the L'Hopital rule. So confirm it first. Substitute to see if you get it. You need the confirmation, remember. So to confirm it, solution, that's it. I have the limit of, you can substitute here, we don't mind. Cosine x over x squared, x goes to 0. If you substitute, that gives you what? 1 minus cosine of 0. Okay, and this is going to be 0. Remember, cosine of 0 is 1. So that gives you 1 minus 1 over 0, which is going to be 0, 0. So it's in determinate form. Okay, so what you're going to do, you're going to use the L'Hopital rule. So you start it over, start with the given one. So that take you back. It's going to be the limit of, I repeat it again, cosine x over x squared. X goes to 0. You have to repeat with the original 1. Now you claim that I'm going to use the L'Hopital rule. Okay, so that would be the limit of x goes to 0, differentiate. Derivative of the top and derivative of 1 is 0. Okay, there a cosine is a negative sign. Okay, so this is going to be the case. This is going to be negative sign. There is a negative here. This is going to be 0 minus negative sine x. And the bottom one would be 2x. So that would be equal to the limit of, the top would be sine x. The bottom one is 2x. X goes to 0. Okay, and now you try again. If you try it again, substitute 0. So that gives you sine of 0 and over 0. Sine of 0 is 0. So we get 0, 0 again. So it means we have to continue. Okay, you continue again. Continue, another application of the L'Hopital rule. So that takes us into the limit. Remember, as long as there is an x, it's limit, limit, limit. Derivative of the top, cosine x. Derivative of bottom one, derivative of 2x, 2. Now replace x by 0. So that gives you cosine 0 over 2. Cosine 0 is 1, so that gives you 1/2, the final answer. Okay, so there you are, the limit of the original 1 minus. You don't have to rewrite it. We understand that if you end up here, okay, over x squared, when x goes to 0, that gives you 1/2. And you are done. You see, these are the most interesting examples or the cases of the, okay, of this L'Hopital rule. Any question? That's the case 1. The case 1, when you get the 0, 0. This is going to be the case 1. Ready for case 2? This is the most popular one. The second one is much, much more popular for calculus 2. The case 2 is that you find the limit, but you are not going to get a 0, 0. You get infinity over infinity. It's the same thing. You can use the same theorem, okay? It's like using a change of variables. So case two, indeterminate form. Okay, indeterminate forms, this time of type, okay, of type infinity over infinity. That is going to be considered to be typed. Again, you try to find the limits, you arrive at the infinity over infinity. So again, you cannot decide. So what you can do, you can use the same idea, the L'Hopital rule again. So we just remind you that the L'Hopital rule, okay, that is going to be L'Hopital's, okay, L'Hopital rules can be also applied. Can be also applied. Okay, to this case, if that's going to be the case. Okay, so if this is going to be the case that limit of you try limit of f of x over g of x goes to a is equal to the, okay, is equal to the infinity over infinity. Okay, you check it, it's going to be the case. So in this case, if the limit of, again, the derivative, f prime of x over g prime of x goes to a, happen equal to the L, then original limit is also equal to the L. F of x over g of x goes to a is also equal to the L. Okay, so that procedure that we did can be applied in both cases to get these numbers done. Okay, just give me 1 second. I have to grab a pen. Okay, so this is going to be the case. So the case of the 0, 0 or infinity over infinity. Again, there are many, okay, there are going to be many problems, but the one that's going to be used quite a lot in calculus, okay, in calculus 2, there are going to be 2 different cases. So I give you both of them. You don't need anything, you don't need any complicated one. You should be able to take care of these type of problems for us, okay? So what is going to be those cases? Okay, I'll go to the next page to explain. These 2 limits are going to be all over the places in calculus 2. You use it in several places during that course. And in general, we want to find each limit. So that would be, you give one question, 2 parts. So the first part would be just 0 over 0. So this is the second part. And find each limit. Okay, and that famous limit is this. So go number 1. It's a limit of, you see there's going to be ln x on the top. On the bottom is going to be power of x, whichever power you like. X squared to the 10 to the 4. So different problems that you may have in this section is going to be involving different power of x. So let's try x cubed. Okay, x cubed, and x goes to positive infinity. See, that's going to be the case. Now, for this type of problems, we have to remind you that, okay, the limit of, we did this one before, limit of ln x, when x goes to positive infinity, is always a positive infinity. So you need to know this one. Okay. So what we're going to do, we try to find it first. So the solution is going to be the limit of ln of x over x cubed when x goes to positive infinity. So it would be equal to the limit of the top divided by the limit of the bottom. Limit of the top is infinity. Okay, and the limit of the bottom is just power of x. The power function is going to be infinity. You see? So we have a case. We have to apply the L'Hopital rule. So what we're going to do, we are going to rewrite it. So we start with the given one. This is going to be limit of ln of x on the top, x cubed on the bottom, x goes to positive infinity. So apply the L'Hopital rule again. L'Hopital rule, that's it. Remember, it's going to be equal to the limit of x goes to infinity. Now, derivative of the top. Derivative of ln x, 1 over x. Divide the derivative of the bottom by derivative of x cubed, 3x squared. That's it. Now you simplify it. It's like dividing two fractions. In the top, you may think about this one, 3x squared over 1. So it's going to be equal to the limit of x goes to positive infinity. The top one, 1 over x, times it by the reciprocal of the bottom one. Reciprocal of the bottom one would be 1 over 3x squared. Okay, so this is going to be equal to the limit of 1 over 3x cubed when x goes to positive infinity. Remember, that was the pizza problem that we did before. The top is a pizza, is a fixed number. The bottom, when x goes to infinity, would be infinity. So you have a pizza, you want to divide it by infinity. You want to divide the infinity many parts. So your parts are going to be nothing. So this limit is always equal to the 0. Okay, the answer to this type of problem is always 0. Okay, so the original limits, limit of ln x over x cubed, when x goes to positive infinity, is simply equal to the 0. It's a very easy case, but very important, the application problem. It doesn't matter which power you have. So in general, but remember, you cannot use it. You can use it for your information only, but you have to prove it any power we give you. In general, the limit of, you see, ln x divided by x to any power, when x goes to infinity is equal to the 0. And this power must be a positive number. You see, it's just for your information. You know the answer is 0, but you have to prove it for us, okay? You have to prove it, but it's nice to know that this is going to be a situation they're going to have. Some people, they have a little bit, not going to be easy when this power, you know, there's going to be radical here. So I do 1 for you, you know the result, it must be 0. But the way you know, you handle it. Any question? Very famous limits. Use it in different parts of calculus 2 or in general, it's a popular one. Let's give you something with a radical. So in case you see it, you are not going to worry about it. You see ln x, something like, how about, let's have cube root of x when x goes to positive infinity. You know the answer must be 0. But you have to show it, you have to prove it. Okay? Again, confirmation, solution, confirm. So the limit of ln x, okay, limit of ln x over cube root of x, cube root of x when x goes to positive infinity. Again, limit of infinity is infinity, and the limit of the cube root of x would be infinity. So infinity over infinity, this means we have a case in the determinate form. So apply the L'Hopital rule. You want to apply to differentiate it. So starting the original one, Be precise, you see, as I writing down. This is the given one. X goes to positive infinity. Remember, you want to differentiate. You better change this radical first. Remember, always we rewrite the radical. So it's equal to the limit of, okay, the top would be ln x. That's cube root of x would be x to the 1/3. Okay, x goes to positive infinity. Now let's see how you handle it. Hospital rule. Put the derivative of the top on the top. It's going to be limit of. Okay, x goes to positive infinity. Derivative of ln x, 1 over x. 1 over x. Derivative of x to the 1/3, you see, 1/3. X to the 1/3 minus 1, which is a negative 2/3. Negative 2/3. Okay, now you've got to be careful how to handle this part. To get this, there are different ways to do it. You can move this one up, or you can switch this back to the positive power. First, going to be limit of 1 over x. Positive power, that give you 1 over 3 x to the 2/3. Okay, x to the 2/3, then x goes to positive infinity. Now it's a division of two fractions. You write the first one, multiply by the reciprocal. Reciprocal would be what? Would be 3 x to the 2/3 divided by 1. X goes to positive infinity, you see? Then you just divide. You see, 3 is a number. 3 is a number, but this is x to the 2/3 over x. So 2/3 of x, the result would be 1/3. So it's going to be limit of 3 on the top, x to the 1/3 on the bottom. X goes to infinity. You see, you get a pizza, a number on the top, infinity on the bottom. A number divided by infinity would be 0. Or you have a pizza divided by infinity many parts. Each part is going to be very tiny part. So this is again is equal to the 0. You see, the limit is always 0. But you have to know, you have to write down carefully. So this is in case you see in your assignment in your book, you have a couple of them with the radical. It doesn't matter. You've got to be a little bit careful when you're dealing the algebra part, but otherwise it's always equal to 0. Any question? So that's the case infinity over infinity. Again, you confirm first. There's ln on the top all the time. So ln of the infinity is infinity. Then we have a cube root of x. We change it. We switch it to the x to the 1/3 to be able to differentiate it. Now we are ready to use the L'Hopital rule. Differentiate the top 1 over x. Then you have to take care of this one algebraically. Different way to do it, you can switch it into the positive power, reciprocal, and multiply the first one by the reciprocal of the second, and you arrive at, you see, x to the 2/3, and this is x to the first power. X to the 2/3 out of the x, or 2/3 out of 1. 2/3 out of 1 would be 1/3. So we get an x on the denominator, you see, and then the top is a fixed number, so the limit would be 0, and then you're done. Okay, so that's going one case. Any question? So this is the group 1 of this example. This is group 2, which is very popular. Okay, very popular again for application in future. What is this group? You see, this group is again something which we can use common sense to find it. But in this course, you have to prove it for us. Look at this one. It's going to be a limit of x goes to positive infinity. The top is the power of x. Any power you like. It doesn't matter. X squared to the 3rd, to the 4th, to the 5th. So let's have to the 3rd. But the bottom one is going to be exponential function, e to the 2x. You see, that's one. is always the case, very popular case for calculus 2 or application problems. The way we do it in future, we just have a look at it and we give the answer. Let's see if you can check for yourself. You see the top is cubic function. So whatever you substitute for x, you cube it. The bottom one is exponential function. Exponential function. So when you compare them together, the top is a power function, means power of a number. The bottom one is exponential. Exponential function, remember, exponential means what? Exponential means fast and big. Exponential. You see, this function is exponentially increasing. This means as you go from left to right, the value of the function getting bigger and bigger and bigger quickly. So when x goes to infinity, which of these reach infinity first? The top or the bottom? Any suggestion? If you pick a very big number for x, if you pick a very big number for x, which of those quantity would be bigger? The top or the bottom? Any suggestion? Suppose x goes to 1000. We have an answer. Let's see. Yes, you know what? That's it. You're right. The bottom. See, the growth of the bottom is much, much higher than the top because it's exponential function. See, if you replace x by 10, for example, the top would be 1000. But if you check the second one, e to the 20, with your calculator, it's going to be quite a lot. So the growth of the bottom is much, much higher than the top. So this means when x goes to infinity, the bottom one will reach infinity quicker than the top. So you get a pizza problem. A number on the top, infinity on the bottom, this limit is always 0. We accept it, of course, if you are in calculus 2. And sometimes they ask you to prove it. Okay, this is just for your information on the test. You have to prove it for us. In this course, so we know the answer, but we have to prove it. How are we going to prove it? Of course, when x goes to infinity, this is infinity, and you must know this. You must know the fact that the limit of e to the x, whatever x you have, x goes to positive infinity is always positive infinity. Because exponential function, remember the graph of this function, up, 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 up forever. So you must know this. So we are going to get the confirmation of our guess. Remember that was just a guess. So confirmation first, set the limit of x cubed, e to the 2x, x goes to positive infinity. As we talk about it, the top would be infinity, the bottom one would be infinity. So it's indeterminate form. Of course, we have to use the L'Hopital rule. So we start it over. So that would be the limit of x cubed, e to the 2x. Okay, x goes to positive infinity. So this is going to be L'Hopital rule. So it's going to be limit of x goes to positive infinity. Now the derivative. The derivative of x cubed is 3x squared. Exponential function never change, but u prime is 2e to the 2x. Again, x goes to infinity, the top and the bottom would be infinity. So this means you have to continue. Once more, L'Hopital rule, limit of x goes to positive infinity, differentiate. Derivative of the top would be 6x. The bottom one, exponential function, would be exponential function. U prime would be 2. There is a 2 here. 2 times 2, 4. 4e to the 2x. Again, it goes to infinity because of the x on the top. Infinity over infinity. So we are not done. Continue. Once more. L'Hopital rule. So that gives you the limit of x goes to positive infinity. Differentiate. If of 6x, 6. If of the exponential function, your prime is 2. 2 times 4, 8. 8 e to the 2x. You see, you got a pizza on the top, a number. You got a number on the top, the bottom would be infinity, so this would be 0. Okay, so you may have to go, depends on this power. If this power is going to be higher, then you have to continue. You have to continue to get a fixed number on the top. When you get a fixed number on the top, the bottom would be huge, okay, infinity. So 6 divided by infinity, in that case, if you like, is going to be equal to the 0. So the original one, limit of x cubed over e to the 2x, x goes to positive infinity, is going to be what? Is going to be equal to the 0. And you're done. Any question? Again, for your information for future, but you are not going to use it as a, you can use it as a, for guessing the result. In general, the limit of any power, x to the p, e to the x goes to positive infinity is always 0. 0, of course, if the power is positive. So, you see different power, but you know the answer right at the beginning. Okay, so it doesn't matter. It's x squared, x to the 5th, to the 6th, radical x, cube root of x. It's always 0 to get this number. Okay, this number to true, if you like. Okay, so this is two groups we are interested in really. There are some very complicated ones, so there's no action, no use. Just to remind you that if you switch it, see, if you put the power down the denominator, if you have something like the limit of, let's have e to the x on the top, just to, to have a complete record. If you have this one, we say if the exponential one is going to be on the top. So after a while, you know that after a couple of cases, you get a pizza down the bottom, or the growth of the top is higher than the bottom one. So when it goes to infinity, the top would be infinity right away. So in this case, this limit is going to be infinity. That's a special case. I just wanted to see it. So if you try it, you will see it. Limit of e to the x over x squared. X goes to positive infinity. It's infinity over infinity. Again, apply the L'Hopital rule. So that gives you the limit of e to the x squared. Okay, x goes to positive infinity. And that's going to be L'Hopital rule. So that gives the limit of, if of e to the x is just e to the x, if of x squared 2x, okay, x goes to positive infinity. Again, this is going to be infinity over infinity. You have to continue to get a fixed number down the bottom. So, L'Hopital rule, that gives a limit of x goes to positive infinity. The top would be exponential function, the bottom one would be 2, a fixed number. So in this case, the limit is positive infinity. Okay, so just to know the difference. Limit of e to the x over x squared. When x goes to positive infinity, this limit is a positive infinity. So if you have the exponential function on the top, it's not going to be a good case. In calculus 2, you have sequences. Sequence is a function defined on the natural numbers. So we have e to the n over n squared. When it's going to be infinity, they say the limit is, they say the sequence is divergent. This is the one we call it convergent. It's converge, they are all coming around the 0. But diverge means they are getting apart, separated. Okay, so this is the way you are going to use it in future. Okay, that is the case 2 that we have. Any question? So officially, we are going to give one more case, but there are several other cases. I just give you a hint, but I'm not going to question you because this is part of the calculus 2. But it's good to know it. You can keep it in case you want to take that course. But you have 2 questions, 2 parts. One part is going to be either infinity, or 0, 0. The second part, of course, is going to be the next one. Okay, let's check the next one as well. Any question? So it's going to be the one. So I just remind you that I have I have created a channel on YouTube because I've been teaching at the university and here all the during the pandemic. Okay, I have a number of the online courses. So I posted those lecture notes. I'm also posting your course as well. So in future, if you want to refresh your memory regarding this course, you can get and see the lectures again, okay? And if the calculus 2, calculus 3, linear algebra, discrete mathematics, all of them, all the courses that I have already done are over there. So I just give you the address in case you want to keep it. If you search my name, you will see it right away. And this is going to be the one at HZZ10, okay, 76. You search this one, you will see it, and then there is a playlist, all the courses, depends which course are you going to be interested in. Calculus 1, 2, 3, linear algebra, discrete mathematics. In future, in case you are going to, okay, so if you search this one, you will see my channel, or otherwise you should search my name. That is Haydar Zahidani. Okay, because you are not going to have access to the canvas at the end of the course, so you cannot have those videos again. But if you want to see them, they are going to be here. Okay, you go over there and then check the calculus one. Okay, it's just for information in case you want it. So let's give you the third case. So what's going to be the third case is going to be indeterminate. Okay, that's it, indeterminate. Indeterminate forms of type. Okay, the type is 0 times infinity. You see, it's going to be the one. So this is again a very popular case. You have two topics in calculus 2 that you have to take care of. This one, 0 times infinity, and there is only one famous limit that we are going to use. And so we focus on that one only, and you don't need anything else really. Now, what is this case? You see, you try to find the limit of the product this time. The limit of the product, the limit of the first one happened to be 0. The second one would be infinity. You know that 0 times any number would be 0, but it's infinity, it's not a number. So that's why we arrive at the indeterminate form. So how are we going to handle this one? To handle this one, we want to use the L'Hopital rule again. But the L'Hopital rule can be used only for quotient, not for the product. So what you have to do is, you have to rewrite this, the product. You have to rewrite this product as a quotient. Now, how are we going to rewrite a product as a quotient? You see, the choice is going to be, you can keep one of them, then multiply by the reciprocal of the other one, or divided by the reciprocal of the other one. Let me just write it down. You see, in this case, this is it, 1 or V. 1 can apply the following identities. The following identities. What is this identities? You see, identities are going to be, if you have F times G, F times it by G. If you would like to make it as a fraction, this way you can do it. You can get a fraction, put one of them on the top, it doesn't matter, F. But divide by the reciprocal of the second one. Reciprocal of the one would be 1 over G. You see, that's it, flip. So F times G would be F over 1 over G. So what is tell you about this one? If this is 0 times infinity, you see, if this is going to be 0 times infinity, so you change it into what? The one that give you 0, you put it on the top. The one that give you infinity, you are going to make it into a reciprocal. But you know that 1 over infinity If you divide 1 into infinity many parts, the result is going to be 0. So that give you 0, 0. Then you'll be able to do the job. Okay, when we get the 0, 0 in that, of course, it's not going to be all in limits. Okay, so if you use these ideas, you change it to the 0, 0, and the 0, 0, you can handle it using the Hospital rule. It's one choice. The other choice is, it depends what you want to do. It depends. You have to think about the next step. The next step is, you have to differentiate the top and the bottom. So try to make it so that the result would be easier to handle. The other choice is, this is f times g. So what you're going to do is you like to keep the g. So you keep the g on the top if you like. Then you have to reciprocal of the f. Reciprocal of the f would be 1 over f. You see? Now, if this is going to be your case, the way you did it, so it's going to be the same as the way you did it, you put the infinity, you keep the infinity. So you have to use the reciprocal of the 0, it's going to be 1 over 0. But 1 over 0 would be infinity. So you change it to the infinity over infinity and you can handle it. You see, you have to check to see which one is going to be easier for you, but you are ready for it. So one can apply the following identities to convert as I did it. To convert, okay, 0 times infinity into infinity over infinity or 0 over 0. Okay, so you convert it. So you can apply the, then you can apply, then if you like, apply the L'Hopital rule to find whichever limits, the limit. Okay, so that conversion is not a big deal, but some people, they missed it. They missed it the way they do it. Okay, and some people on the test, you see, remember in both cases, you need the reciprocal of the second function. The only difficulty is some people, they write this one f divided by g. It's not. It's not. You have to have the reciprocal of one of them to be able to do it. Okay, and this is going to be the standard example that we are going to do. Okay, we give you one of these. It's very popular limits. Okay, there are some other cases we are not going to be interested in. They are not going to be used. So in this level, this would be fine. So what we'd like to do, find the limits. This is it. Find the limit. So what is this famous limit? There are a kind of two. You say it's a limit of a power of x, anything you like. X squared to the third to the fourth. The one that you're using calculus is just x. But just pick any power. It doesn't matter. Let's pick 2. So I pick 2 on the test. They may give you 3 x cubed, x to the 4. All of them the same. That x goes to 0 positive. Why 0 positive? Because of ln function. Remember, the ln is defined for the positive numbers only. And ln is not defined by 0. But when we say 0 positive means you are getting closer to the 0 from the right, and you never get to the 0. Now, when x goes to 0, the first one would be 0. The second one, you must know this one, that the limit of the ln x, you see the limit of ln x, when x goes to 0 positive, this is negative infinity. That's the limit. Remember, this is, you know it from your algebra course, that this is going to be the graph of the ln function. You see this graph is graph of the y equal to the ln x, and this is 1. So when x goes to 0 positive, this is 0. When you're getting and this is a negative infinity, and this is a positive infinity. So when it's getting closer and closer to the 0, then you're going down, down, down. So that's why this limit is negative infinity, okay? So this means for the solution. So this means you want to find the limit of x squared ln x when x goes to 0 positive. So this is going to be 0 times it by negative infinity. So you have the case. Now you have to decide what you want to do. You are going to change this one into the fraction. So you can fix one of the function on the top, divide by the reciprocal of the bottom one. So which one is going to be easier? Okay, you can check this. Okay, so just give you more information before I'm doing it. You see, we give you two options here. Which one are you going to use? Are you going to use this one? You write x squared ln x as, you put the x squared on the top, reciprocal of the other one, 1 over ln x. Are you going to use this one? Or are you going to use this one? X squared ln x equal to, you put the ln x on the top, and you move up the x squared, we flip the x squared. You see? Which one are you going to use? The first one or the second one? Remember, whichever you do, you have to apply the Hospital rule. To apply the Hospital rule, the limit of this is going to be equal to the limit of the derivative of the top divided by the derivative of bottom. So think about this one, the next step. If you do this one, you have to find the derivative of the top, which is 2x. The derivative of the bottom one is not easy. It can be done, but you make things so complicated. But how about the second one? If you do this one, the limit of the top ln x would be 1 over x. Nice. And the bottom one is easier to differentiate because this is simply x to the negative 2. So this is a wrong choice. This is the best choice. Any question? You see, you should think about the next step that you're going to have. The next step is differentiation. You may have to differentiate it several times. But if you do this one, you'll be in trouble because you use the quotient rule. Okay, and things getting complicated. But if you do the second one, 1 over x squared, you make it into the x to the negative 2. No quotient rule, can be done in one step, right on. So for this group of the function, keep the ln x on the top, bring down the x squared. When you bring it down, it's like writing down x to the negative 2. That's it. Then you'll be able to do it right away. Okay, so officially, this is how you are going to handle it. So in short, you say the limit of x squared ln x when x goes to 0 positive. You rewrite it as a limit of x goes to 0 positive. You keep the ln x on the top. You bring the x squared down. You flip it. You're going to be x to the negative 2. Now apply the Hospital rule. Hospital rule. Derivative of the top. So the limit of x goes to 0 positive. Derivative of the top. Derivative of ln x 1 over x. If of x to the negative 2, negative 2 x to the negative 3. That's it. Simplify it. To simplify it, we can move this x to the negative 3 up again. So it's going to be limit of 1 over x times it by x cubed. You can keep the negative 2 as is. Okay, times it by x cubed, and that would be negative 2. X goes to 0 positive. Now, x cubed and x would be simplified. So the leftover would be the limit of the top, you get x squared. The bottom one, we get the negative 2. X goes to 0. Substitute. So that gives 0 over negative 2, which is equal to 0. Done. So the limit is always equal to the 0. So the limit of x squared ln x when x goes to 0 positive is equal to the 0, and then done. See, very, very easy procedure. And it doesn't matter whichever power you have. You see, again, for your information, in general, any power of x, you see the limit of x to the p ln x. When x goes to, okay, when x goes to 0 positive, it's always 0. Of course, if this power is a positive number. You see, when you are going to be in future, if you take these courses and the future, if you want to apply it, you apply this one, this formula, you know it in advance. But this is calculus 1. You have to prove it for us. Okay, so very easy cases that you're going to have. And I'll give you one more example. Let's give you a break. We come back, there is another one like the exponential function. This is x squared ln. You may have x squared e to the negative 2x5x. That's going to be using calculus 2. Then we finish it. There are a couple of more cases. I just explain it, but I'm not going to question you on this. Okay, so it's a 9:11 over here. You have a 15 minutes. It's come back on. Okay, and 9:25. I explained those and we are done. There are a couple of cases that you may use it in future, but we are not going to question you because that would be too much for your course. Okay, so see you in 15 minutes. Okay, so let's check the last case that we have over for this group. So another example, that's x squared ln x. Similar one can be given by the the exponential function, so that we have all of them here. So we have all of them in the review that are posted for you. Your practice quiz, we do it tomorrow. Okay, and again, when we go over the practice final. So the second example is very similar. It's a limit of, okay, for example, we want to find the limit of x squared e to the negative x. Again, when x goes to positive infinity. Okay, this would be the other types. Again, when x goes to infinity, this would be infinity. This is e to the negative x. So when x goes to positive infinity, this limit would be 0. So the limit of e to the negative x, you see x goes to positive infinity, is going to be 0. It's like, the limit of 1 over e to the x goes to infinity, and this is 0. So the case is, again, infinity times 0. So the solution is going to be, this is the limit of x squared e to the negative x goes to positive infinity. So this time you get a positive infinity times 0. So you have to switch in the quotient. This is easy because this is e to the negative x, you bring it down. So it's a limit of x squared e to the negative x goes to positive infinity. We rewrite it as a limit of x squared. We flip the other one, this time e to the x. You see, in the case of the ln function, you keep the ln on the top. But in the case of the exponential function, you keep the power function on the top. That's the difference between these two. Okay, so that's going to be the case. Now we have the infinity over infinity, and we can apply the L'Hopital rule to get it. Okay, so apply the L'Hopital rule. So that gives the limit of derivative of the top would be 2x, the bottom one e to the x goes to positive infinity. Again, this is infinity over infinity. So we have to continue once more. So if you differentiate again, that gives you 2, and this is going to be e to the x goes to positive infinity. Now you have a number on the top, infinity on the bottom. So again, it's a pizza problem, and the result is going to be 0. So the limit of x squared e to the negative x, when x goes to positive infinity, that would be also 0. You see, these are the popular cases that you are going to see in future. Okay, any question? Now, that would be the cases that we're going to be questioning you on this. But if you continue to taking different limits in future, there are going to be a group of them that's going to be using calculus 2. I explain it, but we are not going to even question you on the quiz and on the final. But it's a kind of a general method that's not bad to know it. You see, these are going to be in the 10-minute form of these. Okay, so this is going to be case, just a couple of cases together. I explain it over here. Let me just, are you done with this? You see, this is for future. You are not going to be questioned on this, but the method is interesting to know. Indeterminate. Okay, it's going to be indeterminate forms of types. You see, the types are 0 to 0, infinity to 0, 1 to infinity. These are the, just the most popular one that you're going to see. Let's see when this would happen. This would happen when you see when you have an exponential kind of function. But your exponential function are not going to be the type that we did. It's going to be of the following type. You see, a function. It's a kind of method that is going to be used in future, not bad to know. a function of the form, okay, of the form y equal to, you see I have a function f of x, then you raise it, okay, to the power g of x. No, something like x raise it to the x. You have something like x to the secant x sine x in your book. X to the 1 over x. These are the ones that we're going to be interested in. So if you want to find the limit of this type of function, you make it one of these cases. Because you have the function to the bottom, you have to find the limit of the bottom one and the top one. So we want to know how we're going to handle it. Okay, so a function of this type may result, okay, may result in an indeterminate form. Okay, indeterminate form of the following types, okay, of type. The types that you may have is the one that I listed, 0, 0, infinity 0, or 1 to infinity, because these are not number. You cannot say that 0 raised to the 0 is 1, because, you know, any number, yes, any number raised to the 0 is 1, but not the 0 here. It's, you may get 1 or you may not. So we are not sure at the beginning. So we have to check it to see if this is going to be the one. So if you have this type of thing, now how are you going to find the limit? You see, if you want to find the limit of this type of function, you just, we would like anything you want to do in calculus, when there is a function on the top, you have to bring it down. The only way that you can bring this function down is if you have a natural log. So as soon as this would be given to you, so you have to take the ln of both sides to bring that function down. You see, to find the limit of this function, the limit of the function of this type of functions or function. So what we're going to do, we are going to apply the natural logarithm. Okay, so what you get? So you're going to have ln of y equal to the ln of f of x, okay, raise it to g of x. Then you know that this is the log. You can bring the g of x down. So ln of y would be g of x times ln of f of x. You see? As soon as you bring the g of x down, you see this would be like the one that we did before. If this is the case, it would be 0 times ln 0. Remember, ln 0 is infinity, negative infinity. If this is going to be the case, it's going to be 0 times ln of infinity, which is infinity. If this is going to be the case, it would be ln 1, which is 0. So all of them would be changed into the 0 times the infinity, and then you'll be able to do it. Okay, so apply the natural log to convert, okay, to convert the limit to an indeterminate form. Okay, indeterminate form of type 0 times infinity. You see, this is the procedure that we do it. But in general, in calculus, anything you want to do this function, even if you want to differentiate it, bring it down first. How am I going to bring it down? ln function. If you want to differentiate both sides. If you want to find the limit, you take the limits. But first thing to do, bring it down. Bring it down by the ln function, then the rest automatically would follows. Okay, we just want you to make sure you know this procedure, because this is the procedure that is going to be used in quite a lot in calculus 2. I give you 2 examples and both of them are used in calculus 2 in general. Okay, so 2 very famous limits. But again, we are not going to question you on the tests, but you need to know them. Okay, find each limit. It's good to know these techniques. This is the first one. Okay, you want to find the limit of x raised to the 1 over x. X goes to positive infinity. There's a group of famous problem in calculus 2 that you end up with the fact that you have to know this to be able to do it. Limit of x to the 1 over x, x goes to infinity. Okay, you see if you substitute x goes to infinity, this would be infinity. And that would 1 over infinity, which is 0. So this is infinity to the 0. Solution, if you want to try it, you say, oh, the limit of x raised to 1 over x, x goes to positive infinity, this would be infinity. Infinity to 1 over infinity, which is infinity to 0. So that will tell you that you have a case. So how are you going to take care of it? You go back, you call this one y to bring it down. So you are going to set up, you have to do the algebra. Suppose y is equal to the x to the 1 over x. Now do this procedure that we talked about it. Take the ln of both sides. So I'm going to go to the next page. Any question? Just to show you this famous techniques and the famous limits, of course. So I rewrite it here for myself. So I have y equal to the x to the 1 over x. Take the ln of both sides, ln y. Ln of x to the 1 over x. As soon as you get the ln, you bring the power down. So you bring the power down, that give ln y equal to 1 over x, ln x. You see? Which is like ln y equal to the ln x over x. You see? Now that's one. Now, if you want to differentiate, you differentiate. But you want to find the limit. Take the limit on both sides. Limit of ln of y, x goes to positive infinity, is equal to the limit of ln of x. We see one of those cases that we created and we find out. You know that that would be infinity over infinity. Now we apply the L'Hopital rule. L'Hopital rule that gives you the limit of derivative of ln x 1 over x, derivative of x is 1. X goes to positive infinity. So that would be the limit of 1 over x, x goes to positive infinity. You know that if it's a problem, 1 on the top is like 1 over infinity, which is equal to the 0. So what do you have? You have the limit of ln y when x goes to positive infinity is equal to the 0. Any question? But remember, you are interested in limit of y, not ln y. Limit of x to the 1. No, what we're going to do, there's a trick here that we're going to apply. Ln function is continuous, so we can take this limit inside. So this would be ln of the limit of y, x goes to positive infinity, equal to the 0. But remember the natural log, the base is e. So this is going to be limit of y, x goes to positive infinity, is equal to the e to the 0. But anything to the 0 is 1. So always at the end, you switch it. At the end, when you do the limit, you find always limit of the ln y. So to get the limit of the y, you take the limit inside, and then ln of what is equal to the 0. You see? you see that you know that the limit of 1, ln of 1 is 0. Or just is a log at the base e, so this would be equal to the base e to the 0, which is 1. So there you are, you prove a very famous limit in calculus. Limit of x to the 1 over x goes to positive infinity is always equal to 1. Okay, again, you know, if you continue, there are a couple of cases in calculus 2 that we use this limit. There is a test, they call it the ratio test. You need it, so it's nice to know it, get the experience, although we are not going to question you. But you learn something very, very special for future. This is one of them. I give another one. Any question? So these are, you know, you have in your book some very silly examples. X to the secant of x, sine x to the cosine of x. They are all useless, but you should be able to apply it to get these type of problems and know the idea for future. Okay, the last example that I gave you again is very famous limits. Remember this number e when you took calculus, pre-calculus? They try to justify for you what is e. E is 2.73. So the way we do it, let me write the limit. You see, this is the limit that we want to find. What is the limit of 1 plus x to the 1 over x? Okay, when it goes to 0 positive. There are, of course, two versions of this. This version is easier to handle. You see, that would result the number e for you. And so you may try to find it, substitute. If you substitute, what's going to be the result? Is the ln of, I repeat it, 1 plus x to 1 over x goes to 0. If you substitute, that gives you 1 plus 0 to the 1 over 0. So that gives you 1 over 0 would be infinity. So indeterminate form, because you know 1 infinity is not a number. So what you have to do, you have to go back, you have to bring this one down first, remember? So as usual, you suppose whatever it is, you call it y. You take the ln of both sides, ln of y, ln of 1 plus x to the 1 over x. Bring 1 over x down, ln of y, 1 over x, ln of 1 plus x. Again, this is like ln of y equal to ln of 1 plus x over x, you see? Now what do you want? You want the limit of the y, so take the limit. If you want to differentiate it, you differentiate. But take the limit of ln of y. This time x goes to 0 positive. It would be the same as the limit of x goes to 0 positive of this function, ln of 1 plus x over x. Substitute 0 for x. So it would be ln of 1 plus 0 over 0. It's going to be ln of 1 over 0, but ln of 1 is 0. 0, 0. See? So we have to use orbital rule. Orbital rule is going to be limit of x goes to 0 positive, differentiate. Derivative of the ln function is ln u. Derivative would be u prime u. U prime, derivative of 1 plus x, 1, divided by u, 1 plus x. That's the derivative of ln of 1 plus x, derivative of x, 1. So that gives a limit of 1 over 1 plus x when x goes to 0 positive. The result would be 1. So you get the fact that the limit of the ln y when x goes to 0 positive is equal to 1. but you are interested in the limit of y. So what you are going to do again, you take the limit inside, that give you ln of the limit of y when s goes to 0 positive is equal to 1. The same thing that we did for the other one. So this means that the limit of, okay, so that gives you the limit of the y. When x goes to 0, the base is e. It's going to be e to the 1, which is equal to e. So you prove a very famous limits. Limit of 1 plus x to the 1 over x goes to 0 positive is e. This is another way to introduce the number e. Again, a very popular problem for calculus 2. There is a one version in calculus 2. We switch this one into this form. It's the limit of 1 plus 1 over x to the x. X goes to positive infinity. It's the same thing. This is the one that they consider to be definition of the e, and they expect you to know it. Okay, from time to time. In college algebra, the way you introduce the e, they give you a table. You see, you make a table and you replace the x by 1, 2, 3, 10,000, a million, 10 million, etc. Then they tell you that, oh, this number is getting closer and closer to the 2.73. And then they tell you that this number is going to be called E, okay, Euler constant. But this is the precise proof that show you that, how you arrive at the definition of a number E. So I just wanted to see the application of this argument and why we are interested in. So it's the two famous limits, and knowing it would be enough. But again, in calculus 2, they are going to repeat it again for you. But I wanted to know this idea that if there is something like this, if you want to do anything about it, you can't do it. You can't find the limit. You can't find the derivative. You better bring it down. You take the ln of both sides. When you arrive at this equation, then you decide. If you want to differentiate, derivative both sides. If of ln y would be y prime y, and you differentiate this, and you'll be able to do it. Okay, so that is all the cases for the indeterminate form. So one question, two parts for this test and for the final. We are not going to give you exponential, so you may get a 0, 0, infinity, infinity, 0 times infinity. That is an extra section, that I talk about it, that officially was not part of the deal for calculus 1, but it's good to know it. So we are going to be level with other places that they take calculus 1. Okay, so we are ready for quiz 4. So what I'm going to do, I'll go over the practice quiz number 4 tomorrow for you. And that will be part of the final review. It's very important. The practice quiz takes time. We use the full hour to do it. And then, of course, it would be part of our final review. Okay, that's it for today. Tomorrow, the review. Monday, I just talk about the inverse trigonometric function, and I go with more problem for you on Tuesday. And the test start with Tuesday, Wednesday, Thursday, but we won't have any class on Wednesday and Thursday. Unless you have any question, you let me know. Okay, that's it. Any question? So have a good one and be prepared for, if you have done your test, just work on the practice quiz. Your last sets of assignments, I'm going to post it, but it's going to be collected by the final day because we want to I want to cover all the sections, then I ask for the problems. But I'll post them later today in case you want to do it in advance. Okay, that's it. Take care. Have a good one and see you tomorrow. Bye-bye.